Welcome to the Linux Fundamentals Part 3. That's going to be the last part of the Linux Fundamentals series. Let's get right into the introduction. And as always, if you haven't done Linux Fundamentals Part 1 or Part 2, it's highly recommended because Part 3 does build off of those two. So the introduction. Welcome to Part 3 and the finale of the Linux Fundamentals model. So far throughout the series, you've got hands-on with some of the fundamental concepts and used some important commands. This room is going to showcase some of the useful utilities and applications that you are likely to use day to day. You're also going to advance your Linux FU skills by learning about automation, packet management, and service application logging. And on to task 2, deploying the Linux machine. You see, I've already deployed it. And here you have the start machine, and then as well, up top, there will be a start AttackBox button, so you'll want to hit that as well. So what we're going to have to do is log in through SSH, secure shell. And if you don't remember the command, it's just SSH, and then username that you're trying to log into remotely, TryHackMe, at the IP address that you're logging into. That's going to be 10.65.167.88. And yes, and the password here is saying the password is TryHackMe. And I am now in. We're now on to task 3. Terminal text editors. Throughout the series so far, we've only stored text and files using the combinations of the echo command and using pipe operators. So it's not the most efficient way when handling data when you're working with files and with multiple lines. With echo, if you're wanting to put multiple lines inside of a text file, you would have to type the command per each line you want to put in there, and that's not the most efficient way. It's not the quickest way to get things done. In this lab, we're introducing the Nano command. They will also go over the VIM, but TryHackMe is going to go over that. They have their own dedicated room for that, so I'm not going to get too deep into it. Before I get into the Nano command, I'm first just going to do ls to see what we already have in here. Now let's type in nano TryHackMe. Now that I'm in the Nano command, I can write out as many lines as I actually need to for this text file. So we can start with something simple like hello world. Or we can even do something like we want to see your real face. Mad Hat. In this text editor, you can even write whole paragraphs and letters if you really want to. You can even write a cover letter for a job resume if you want to. Like, dear hiring managers, I would like a job, please. So there's a lot of stuff that you can do like that. And now with this, after you're done writing out all of the text in here, hit Central command, hit O for write out, hit enter, that'll save that in there, then Central again and hit exit. And now you could double check that, use the cat command. Oh, dang. Use the cat command, TryHackMe. And as you can see, it's showing out all of that text, where if I wanted to do all of that with echo, I would have had to put all of that in line by line, and it would have been a whole thing that I don't want to deal with. Nano has a few features that are easy to remember and covers the most general things that you would want to get out of a text editor, including searching for a text, you can copy and paste, jumping to a line number, finding out what line number you are on. You can use these features of Nano by pressing the Central key, which is represented by the up arrow on Linux, and a corresponding letter. For example, to exit, we want to press a Ctrl+X, which we already did to get out of Nano. VIM is a much more advanced text editor. While it's not expected to know all the advanced features, it's very helpful to mention it for powering up the Linux skills that you're developing right now, and that I'm developing as well. Some of the VIM benefits, it takes a little bit longer to get familiar with, but it does include customizable. You can modify the keyboard shortcuts to be of your choosing. So it's kind of like when you're playing a video game, how you could go into the settings and you can alter what button does what for the game, so it's ever more comfortable for you. Syntax highlighting, this is useful when you're writing or maintaining code, making it a popular choice for software developers. Vim works on all terminals where Nano may not be installed. There's a lot of resources such as cheat sheets, tutorials, and plenty of other information that's available to that way you can learn VIM and how to navigate it. And this right here, if you want to go directly to the VIM room, this is where it's showing you. Edit task 3 located in a TryHackMe homes directory using Nano. What is the flag? Use the command Nano, task 3, and this flag right here. Just copy and paste that over. Task 4, general, useful utilities. Downloading files, wget. A pretty fundamental feature of computing is the ability to transfer files. For example, you may want to download a program, a script, or even a picture. Thankfully for us, there are multiple ways in which we can retrieve these files. We're going to cover the use of wget. This command allows us to download files from the web via HTTP. And for those of you that don't know, so HTTP, this is the basic protocol over the internet. It's Hypertext Transfer Protocol. This is what you're going to use to traverse the internet, go to Amazon.com, Google, wherever you want to go. And this S right here, this just makes it secure. So it essentially just puts the HTTP inside of a package and protects it and encrypts it. That way, when you are traveling the internet to get to Amazon or Google, it protects your data while it's in transit. So we simply need to provide the address of the resource that we wish to download. For example, if we want to download a file named myfile.txt onto the machine, assuming I knew the web address, it would look something similar to this. We won't be able to obviously won't be able to download this exact link right here for the website. So I'll just have to go off of what they have over here on this side. Transferring files from your host, SCP, SSH. Secure copy, or SCP, is just that. It means of securely copying files. Unlike the regular CP command, this command allows you to transfer files between two computers using the SSH protocols to provide both authentication and encryption. Working on module, source, and destinations, SCP allows you to copy files and directories from your current system to a remote system. Copy files and directories from a remote system to your current system. Provide that we know the username and the password for the user and the current system and the user on the remote system. So for example, let's copy an example file from the machine to a remote machine, which I have neatly laid on the table below. So the top variable right here, the IP address of the remote machine. Then you have the user or remote machine, which is Ubuntu. Name of the file system on the local system. Name that we wish to store the file as on the remote system. With this information, let's craft our secure copy command. Remember that the format of secure copy is just source and destination. So let's go to this command right here. So this right here, so this is just the command, the secure copy command. And this is the source. So this would be on our computer right here, whatever text file we're trying to transfer over. And this will be where we're trying to transfer it to. Ubuntu, here's the IP address. And this is the actual location on that machine where we're trying to transfer it to and what we want to call it. And now let's reverse this and lay out the syntax for the secure copy and copy a file from a remote computer that we're not logged into. And now the command will look more like this. So it is reversed. So here's a secure copy. Here's where we're pulling the file from. And this is what we're going to be calling the file. Now, before I get more into this next section, I'm actually going to use a command from the last lab. That way I can see any sort of hidden files. This right here, as you can see, there's actually quite a bit of hidden files with flag.txt. This is, anytime you see a flag.txt in TryHackMe, it's going to be extremely important. So just watch out for those whenever you see them. And now to get right back into it, serving files from your host, WEB. Ubuntu machines come prepackaged with Python 3. Python hopefully provides a lightweight and easy-to-use module called HTTP server. this module turns your computer into a quick and easy web server that you can use to serve your own files, where they can then be downloaded by another computer using commands such as curl and wget. Python 3's HTTP server will serve as the files in the directory where you run the command, but this can be changed by providing options that can be found within the manual pages. Simply all we need to do is run Python 3-m HTTP server. So here's the command right here. Python 3-m HTTP server. As you can see, is running right now. In the snippet below, we're serving from a directory called web server, which is a single named file. Now let's use the wget to download the file using the IP address that's listed right here, 10.65.167.88, and then the name of the file. Remember, because Python 3 server is running on port 8000, we will need to specify this within our wget commands. Now, for example, so the wget, we would actually have to go onto a different terminal right here. Before I do that, I'm going to go ahead and get the IP address that I will need. I'm going to go ahead and copy that. So I can show you on this. Should be in here. It's the IP address right here that I want to use. Now let's try to run this wget command, and I'm just going to do the flag.txt file. Wget HTTP. Paste that IP address, port 8000 / flag.txt. As you can see right here, it says the HTTP request was sent. It's awaiting the response. And if you go back to the original terminal right here, you can actually see that I'm trying to get the flag called txt. Well, I'm trying to get the file called txt. So it's showing up in this other terminal as well. And now remember, you'll need to run the wget command in another terminal, which is what I just did, while keeping the terminal that is running Python 3 server active. And this is the example that they gave us below, right here. And then this is actually what they did, the flag.txt. One flaw with this model is that you have no way of indexing, so you must know the exact name and location of the file that you wish to use. This is why I prefer using updog. And what is updog? You can just click right here. It'll show you exactly what updog is. And feel free to browse this website, learn everything you can about updog. And I'm just going to get back over here, get back into the lab. So ensure you're connected and deploy the instance 10.65.167.88. And that's exactly what I did right there. Now use Python 3's HTTP server model to start the web server called home directory, TryHackMe user, and to deploy the instance. And that's what I already did right there. Okay. Now I use Python 3's HTTP server model to start the web server in the home directory of the TryHackMe user, the deployed instance. So this is exactly what it did right there. And this is what came up. So download the file of this IP address right here, flag.txt on the TryHackMe. Remember, you will need to do this in a new terminal. Actually, what's supposed to do, since it is a hidden file, hit that period right there. And now flag.txt is saved onto the computer. As you can see, here's another instance that was done with the flag.txt file. No word of the context, so I used the ls-a. And here's the hidden file right there. I'm going to do cat.flag.txt. And that's the contents right here. THM, we get web server. Create and download files to further apply your learning. See how you could read the documentation on Python 3's HTTP server model. Use the Ctrl+C to stop the Python 3 server running. So it's just this right here, Ctrl+C, and now I'm out of it. Task 5, Processes 101. Processes are the programs that are running onto your machine. They are managed by the kernel, which each process will have an ID associated with it, also known as the PID, the process ID. The process ID increments for the order in which the processes start. The 60th process will have a PID of 60. So view processes, we can use the friendly command PS. So PS, this is showing the current processes that we have. We have bash, then we have the PS process. This is the process ID right here, 1044, and then 3648. So we can use the friendly PS command to provide a list of running processes as our user session and some additional information such as the status code, the session that is running at, and how much usage time the CPU is using, and the name of the actual program or the command that is being executed. Note how in the screenshot above, the second process has a PID of 204. Then in the command below it, there's an increment to 205. So if I do that again, you can see that the process ID, the PID, is 3648. If I type that again, now the PID is 3649. And it'll just keep going like that, 3650. To see the processes run by other users and those that don't run from a session, i.e. system processes, we need to provide aux to the PS command, which will be PS AUX. And this shows us the other running processes that are taking place right now. So right here, you see the PS command, the PS aux, which we just did. The process ID is 3651. Here's the bash command from earlier. Go the way up top, you can see the root. Note that we can see a total of 5 processes, and they're talking about, in the screenshot right here, they have root and cmnatic. Another very useful command is the top command. Top gives you real-time statistics about the processes running on your system instead of a one-time view. This statistic will refresh every 10 seconds, but will also refresh when you use the arrow keys to browse the various rows. Another great command to gain insight into your system is via the top command. Let's clear this. Now to go over the top command, just type in top. Pretty simple to get in here. Now you can see all the actual running processes, and it does reset like it says every 10 seconds. And there's actually a lot more you could do with this. So you could just hit the down arrow. You can go down all the way to the bottom, go down all the way to the top. It's a lot of very useful commands that you could do. You could type H. It'll show you the help prompt. That way you can go over a bunch of different commands that you can use. And then to get out of that, just hit Q. Another very useful thing, you could do F. And this is the fields management. So if you ever just try to narrow it down, maybe you just want to see one thing, you could use this to do that. So let's say you only wanted to see the process ID. What you can do while you're in here, you hit the D command, and then you take that little star that's next to all these, and then you just hit the D command against all of them, and that will make all of these hidden. And now hit Q to go back, and now the only thing that you see is the process ID. And then again, you can get back in here. I'm going to put all these back on. Another thing you could do as well, here's all of these down here that are hidden. So if you do want to view these, like if you want to view the group name, just hit D on there, hit Q to get out of that. Now if you hit the right arrow key, you see group, it's TryHackMe root, whatever the group name specifically would be. I'm just going to get right back in here, and I'm going to go ahead and hide the group. Hit quit again. So feel free to just go ahead and browse through the top command as much as you would like, get a little bit more familiar with the commands. And I'm going down to managing processes. You can send signals to terminate processes. There are a variety of types of signals that correlate to exactly how cleanly the process is dealt with by the kernel. To kill a command, we use the appropriate named kill command, and then the associated PID that we wish to kill. I.e., to kill PID 1337, we'd use kill 1337. I'm going to go over how the kill command does actually work a little bit. You do want to be careful with the kill command, because if you do kill active running processes that you do actually need on your computer, you can cause a lot of issues with that. So what I'm going to do, you can see these are the running processes. I don't want to mess with those. I will actually create one called sleep. And what sleep does, sleep essentially slows your system down. and it allows it to only execute commands after a certain amount of time. So right here I have 1000 seconds is what that is. I still want to be able to type in a command or two. So I can show you the kill command. So I'm going to type in the background operator. And now you can see sleep is in there. So what I'm going to do kill, and then I'm going to do the PID, and that's going to be 3666. And as you can see, the sleep process is gone. So that's how the kill command can be used. It can be very useful, but it can be very dangerous. So be very careful with it. SIGTERM, it does kill the process, but it does allow to do some cleanup before the task does get killed. Then you have just SIGKILL. That kills the process, and it kills it right there. Doesn't do any cleanup, doesn't do any of that. Then you have SIGSTOP. That's going to stop or suspend the process. What I did when I just typed in kill and then I put the process ID. So what I sent into Linux, hey, can you please kill this process? And then Linux decided if it did or did not want to kill that process, and it decided that it wanted to. It decided that was okay. Now, if I typed in SIGKILL, it just kills it right away. Linux doesn't decide if it wants to kill it or not, it just kills it. So be very careful with all of that. How do processes start? Let's start off by talking about namespaces. The operating system uses namespaces to ultimately split the resources available on a computer, such as CPU, RAM, priority processes. Think of it as splitting your computer into slices, similar to a piece of cake or a slice of pizza. Processes within that slice will have access to a certain amount of computing power. However, it will be a small portion of what is actually available to every process overall. Namespaces are great for security and as a way of isolating processes from one another. Only those that are in the same namespace will be available to see each other. We previously talked about how PID works, and this is where it comes into play. The process with the ID of 0 is the process that starts when the system boots up. This process is the system's init on Ubuntu, such as systemctl, which is used to provide a way of managing users' processes and sits between the operator system and the user. For example, once the system boots up and it initializes, systemctl is one of the first processes that is started. Any program or piece of software that we want to start will start as what's known as a child process called systemctl. This means that it is controlled by systemctl, but will run as its own process, although sharing the resources from systemctl to make it easier for the identity and the likes. So getting processes, services to start on boot. Some applications can be started on the boot of the system that we know. For example, web servers, database servers, and file transfer servers. This software is often critical and is often told to start during the boot up in the system administration. In this example, we're going to be telling the Apache web server to start Apache manually and then telling the system to launch Apache 2 on boot. And through the use of systemctl, so this right here, let's do systemctl. And now if we go down over here, you do the option. So the options are right here. You have start, stop, enable, disable, and then the service. Where we want to start is Apache 2. So we do systemctl, and now the option, which we want to start it, and then Apache 2 is what we would like to start. Ctl, start Apache 2. Okay. Now it is prompting me for a password, which I'll try TryHackMe, but I don't think that's going to work, which it did not. So I don't have a password for it, but that's how you would actually start that process. An introduction to background and foregrounding in Linux. Processes can run in two states. It can run in the background and it can run in the foreground. For example, commands that you run in terminal, such as echo, or things of that sort, will run in the foreground of your terminal and is the only command provided that hasn't been told to run in the background. So the commands that run in the background is it's the stuff you don't really see. So echo is a great example of the output of echo. It will return in the foreground, but it wouldn't return in the background. As you can see in the screenshot right here, it shows you that, and this is the background operator that it's using. Here we're running echo, hi THM. where we're expected output to be returned to us like it has started. But after doing the background operator to the command, we're instead of just given the ID of the echo process rather than the actual output. And this is the process right here that they're talking about. So this is a great command, such as copying files, because it means that we can run our command in the background and then continue on whatever further commands we do need to execute. We can do the exact same when executing things like scripts. Rather than relying on the background operator, we can use a Ctrl+Z on our keyboard to background the process. It is an effective way of pausing the execution of a script command, like in the example below. So you can see in this example right here, it's saying it's going to keep on looping until I stop it, and then they did background this. So now it's in the background, and now they continue to run whatever command or whatever they need to do. And this is a looping script right here, is what that is. And this script is going to keep on repeating. This will keep on looping until I stop or suspend the process by using Ctrl+Z, as indicated by this right here. Now our terminal is no longer filled up with these messages until we foreground it, which we will discuss below. Foregrounding a process. Now that we have a process running in the background, for example, our script background.sh, we can now be confirmed by using the psaux command, and we can backpedal and bring the process back to the foreground to interact with it. And now to foreground the process, you just type in FG, and that command is going to foreground the process, as you can see right here. And now the script loop is back up and is on the foreground. It's not in the background anymore. So that's just README. If we were to launch a process where the previous ID was 300, what would the ID of this new process be? So that's just going to be 301. If we wanted to cleanly kill a process, what signal will we send it? So we would send it SIGTERM. That's going to cleanly kill it. Locate the process that is running on deployed instance 10.6.5.167.88. What flag is given? So to find that, once again, psaux. We'll look through here. So right here, THM processes. What command will we use to stop the services? My service. So that's going to be systemctl. That's going to be stop my service. What command will we use to start the same service on the boot up on the system? That's going to be systemctl. That's going to be enable my service. What command will we use to bring the previously background process back to the foreground? This is going to be FG, which stands for foreground. Maintain your system automation. Users may want to schedule a certain action or task to take place after the system is booted. Take, for example, running commands, backing up files, or launching your favorite programs on, such as Spotify or Google Chrome. We're going to be talking about the cron process, but more specifically, how we can interact with it via the cron tabs. Cron tab is one of the processes that is startup during boot, which is responsible for facilitating and managing cron jobs, or cron jobs. Cron tab is simply a special file with formatting that is recognized by the cron process to execute each line step by step. Cron tabs require 6 specific values. To have the MIN, that's going to be the minute that's executed at, the hour when it's executed, the DOM, day of month, MON, that's the month, DOW, day of week, and CMD is going to be the actual command that's going to be executed. Let's use the example of the backup file. You may wish to back up the CMNATX documents every 12 hours. So this is what they're going to do. So this right here, you just go right here. What minute is it going to be executed at? So minute 0. The hour is going to be 12. With these 3 right here, you don't need to specify that if you want it to just run every 12 hours. If you did want to run it at a Monday, every 12 hours on a Monday, you would have to specify that. But here it's just every 12 hours when it wants to be ran. And this is the command that it wants to run, the var backups. An interesting feature of cron tabs is that these also support the wildcard or asterisk, just like I was mentioning above. So if you don't need to specify the day of the week, or if you don't need to specify the month, then you could just put the asterisk right there, the wildcard. So this can be confusing to begin with, which is why there's also some great resources such as Online Crow Tab Generator. So whenever you're doing these labs, feel free to just click these, that way you can read through them. It does have a lot of very helpful information. It does also have the site called Chrome Guru, so go ahead and click through that. Just learn all about it as you actually can, because that's the whole point of doing these actual labs, is to actually know what you're doing and to get a good grasp on this field. Chrome tabs can be edited by using Chrome tab-E, where you can select an editor such as Nano to edit your Chrome tab. So right here, this is what it's actually showing right here. Let me do this, Chrome tab-E. And what these hashes right here are, so this isn't anything that's being executed when you see this hash in this blue line. So this is just if you are having any sort of scripts or anything in there, you could put all of this up here as notes, so you know what's going on. So if anyone else goes in there, they can see your notes as well, or if you need to go back to your notes. And then if I go down, you can see if there's anything actually running in here. So what I see here, what is actually running is at reboot, and this is what's running at reboot. Ensure you are connected to the deployed instance and look at the running Chrome tabs, which I just did that. When will the Chrome tab on the deployed instance run? So you can see right here, it's running at reboot. So that's going to be at reboot. Task 7, managing your system package management. Introducing packages and software repos. When developers wish to submit software to the community, they will submit an APT repository. If approved, their programs and tools will be released into the wild. Two of the most redeeming features of Linux shine to light here: user accessibility and the merit of open source tools. When using ls command on Ubuntu 20.04 Linux machines, these files serve as a gateway registry. And you can see, this is the screenshot above. These files that they're talking about right here. While operating system vendors, while maintaining their own repositories, you can also add community repositories to your own list. This allows you to extend the capabilities of your operating machine. Additional repositories can be added by using the add-apt-repository command, or by listing another provider. For example, some vendors will have a repository that is closer than the geographical location. Managing repositories, adding and removing. So with the repositories, I most likely won't be able to do any sort of add repository. Just to show you, apt, most likely don't have the access to that, so must run as root. So what that means is I have to run a sudo, but I don't have the sudo password, so I won't actually be able to get in here. But that's how you would run that. You have to do sudo to run as root, and then the command for add apt repository. So one method of adding repositories to the use of the add adp repository commands we illustrated above, but we're going to be walking through adding and removing repositories manually. While you can install software through the use of packages installers such as dpkg, the benefits of apt means that whenever we update our system, the repositories that contain the pieces of software that we add also gets checked for updates. In this example, we're going to be adding the text editor Sublime Text to our Ubuntu machine as a repository, as it is not part of the default Ubuntu repositories. When adding the software system, the integrity of what we download is guaranteed by the use of what's called the GPG. That's the GNU Privacy Guard. It's going to be those keys. These keys are essentially a safety check from the developer saying, here's our software. If the keys do not match up with what our system trusts and what the developers use, then the software not be downloaded. So it's just like verifying the hash of a file. If the file was altered in any way, even if it's just one letter, or even if it's just the capital of that letter, the hash will be completely different, and that's how you verify the integrity if it's been messed with whatsoever. So that's essentially what it's doing here. So to start, we need to add the GPG key for the developer Sublime Text 3. and this is going to be the command right here. Now, I don't have sudo privileges on this. I don't have the password, so I can't go ahead and actually do this because I'm not actually connected to the internet, so I don't have that ability in this lab. Well, this lab itself is not connected to the internet, so I don't have the ability. Number one, let's download the GPG key and use the APT key to trust it. So this right here is going to be the command. It's the wget-qo the HTTPS. There's going to be the download, the Sublime text, and then there's going to be the key that's added. Now that we've added this key to our trusted list, we can now add Sublime Text 3's repository. Now we're adding to the repository the touch. So just as a refresher, touch is where you create a file, and you're creating the file sublime text.list. And then you're going to use Nano or any text editor of your choice, so you can actually add and save the Sublime Text 3 repository into newly created file. So this right here. Then next, after you added the entry, this is done, you want to do the apt update, which once again, you do need sudo commands to do, so I can't do it on this machine. After you're done updating it, you will now proceed to install the software that I've trusted and added to the apt using the apt install Sublime Text. Removing packages is just as easy as reversing. So the process is done by this command right here. It's to add-apt-repository-remove, and this is what you're removing. Or you can manually delete the file that we previously added. So you do the apt remove and whatever you're trying to remove. And then I read through that. Can't connect to the internet, so I can't exactly do that on this lab. It would be nice, but I can't. Task 8, which is maintaining your system logs. We briefly touched on this in Linux Fundamentals Part 1. It's going to be the var log directory, and that's where the files and folders contain logging information for applications and services running on your system. The operating system has become pretty good at automatically managing these logs in a process what's known as rotating. And below here, they have actually highlighted some of the logs from 3 services running on a Ubuntu machine. You have Apache 2, you have the logs files from these right here, you have the UFC service, which uses a firewall. So this is what they're talking about right here. You have Apache 2, then you have these logs here. Even if I go in here, I could do, where am I? CD var log. And now I don't have exactly the same type of logs that they have on here, but I do have the Apache 2. So on this Linux machine, you could go ahead and explore that a little bit if you would like. These services and logs are a great way of monitoring the health of your system and protecting it. Not only that, but the logs for services such as web server contain information about every single request, allowing developers or administrators to diagnose performance issues or investigate an intruder activity. For example, there are 2 types of log files below that are of interest. You have access logs, and then you have error logs. Yeah, now you don't have any in here, but let me actually see. So it's var log Apache 2. Let's get into Apache 2. And here you have error log 1, you have access log 1, and this is exactly what they're talking about. These are, of course, logs that store information about how the operating system is running itself, and the actions that are performed by users, such as authenticating attempts. Now look for the Apache 2 logs on the deployable Linux machine. So over here, after I went to var log, hit the ls command. Here's Apache 2 right here. And then once I did that, I did cd Apache 2, and I'm now in Apache 2. What is the IP address of the user who visited the site? Okay, let's do cat access log. Cat log 1. After doing the cat command on access log 1, the IP address is 10.9.232.111. What file did they access? They accessed, you can see right here, they accessed catsanddogs.jpg. Conclusion and summaries. To recap this room, we went over using basic terminal text editors like Nano command and Vim, general utilities such as downloading and serving contents using Python web servers, a look in the processes using the PID, PS commands, PS aux, maintaining and automating your system by use of cron tabs, package management, and reviewing logs. You go ahead and continue your learning. Right here, they already have this Bash scripting room, and they already have a regular expressions room. Just like in the last Linux lab that I went over, I'm going to say it again, but if you do have anything in this lab that you don't completely grasp, just go ahead and keep on redoing the lab, play around in the lab, because the only way you're truly going to grasp this stuff and understand how to actually use it is if you just keep on using it and build that muscle memory. And that's going to wrap up this video. So thank everybody for watching, and I'm going to have another one coming out in a few days.